Madam, Durga ma'am, Durga ma'am, Durga ma'am is there online?
Sir, madam is there. Madam is there. She's in
Madam is
line.
there.
Madam, Durga
Okay.
madam.
Yeah.
Durga madam.
Sir,
Madam,
sir.
I think we can. I think it's 16. We can
Sir.
we can begin, madam. So you
Yes,
invite
sir.
the speaker of this session, and you welcome the speaker of this
Sure.
session, and read the profile, madam. Okay, ma'am. Please
Okay.
proceed.
Good evening, everyone. Good evening to all the participants and our resource person and all the faculty members to the last session of our 5 days online faculty development program on advanced signal processing communications using AI and ML techniques jointly organized by Department of ECE of GMR Institute of Technology, Rajam, Andhra Pradesh, and Sri Sairam Institute of Technology, Chennai, Tamil Nadu. Today, our resource person is Dr. Vijayarajan sir. Sir is currently working in WIT Chennai campus. So, Dr. R. Vijayarajan sir has completed his Bachelor of Engineering degree in Electronics and Communication Engineering from University of Madras in the year 1998 and Master's degree in Applied Electronics from Madurai Kamarajar University in the year 1999. He completed his doctoral research in image fusion at Anna University in the year 2015. He is currently working as faculty member with the Center of Healthcare Advancement, Innovation and Research, School of Electronics Engineering, WIT Chennai. He has been in academics for more than 21 years and has published 32 research contributions in various SCI and Scopus indexed journals and conferences. His research interests include computer vision, machine learning algorithms for signal and image processing, image fusion, biocryptography, emotion classification, and deep learning for image analysis. He is guiding PhD scholars in the field of medical image analysis. He is fellow of IETE, life member ISTE, and a member of IEEE. He is also recognized as reviewer for elsewhere journals, IEEE Access, and IEEE transactions on instrumentation and measurements. Vijayarajan sir, we welcome you to this session, sir. We are happy to have you as our resource person. Thanks for sparing your time with us, sir. Now the session will be yours, sir. Thank you very much, sir. Sir, your voice is not audible.
Dr. Vijay is online.
Sir, voice is not audible, sir.
I think sir has left the meeting again to join. Maybe some technical problem. Voice is not.
He's joining, madam. Once again, he's joining.
Okay,
Let us
sir.
give. Yeah, he's joining back. Sir, Vijay sir, I made you as presenter. Now you can share your PPT, sir. Dr. Vijay.
Yes, sir. Can you hear me now, sir?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
I could able to hear you. Now you can share, sir. I made you presenter. Okay.
Thank you, sir. Thank you.
Okay, sir. Okay.
So can you see my screen, sir?
Sir, sir. Yes, sir.
Yeah. Thank you very much for the uh, kind introduction. I would like to thank the management, department, coordinators, faculty members of EC department for having given this opportunity to present the talk on artificial intelligence for medical image analysis. So last 4 days, you might have heard about so many definitions and so many applications of AI. My session is about artificial intelligence for medical image analysis. So over the different sessions, you might have observed that artificial intelligence is nothing but mimicking human brain. That is duplicating human brain. We are somehow successful in duplicating human brain, but we are not 100% successful. We are successful in very less percentage. So we are able to mimic a human brain in certain applications, but in certain applications, we have so many bottlenecks. So overall, you might have observed that we have AI. AI is very big concept. In this big concept, we have machine learning concepts. In this machine learning, we have deep learning concepts. Deep learning concepts. So AI can be introduced to machines by different means. We can go for machine learning algorithms, or we can go for deep learning algorithms. You know that in machine learning algorithms, we have to worry about features. So features and feature extraction is key in machine learning. Feature extraction is key factor in machine learning. But in deep learning, we don't need to worry about feature extraction, but we need to always think about data set. We need to think about data set. So with very good data set, with very good computing facility, we can go for deep learning. In the case of machine learning, we need to extract features. We need to work on feature engineering. We have to pre-process the data so that we can construct the effective machine learning model. So in these cases, we have different types of learning. First is about supervised learning. You might have heard about. Second is unsupervised learning. Third one is reinforcement learning. Reinforcement learning. In supervised learning, we need input as well as targets. For unsupervised learning, just we have input features. We don't need to worry about targets. Based on the relationship among input features, we can go for either classification or any other task. But in the case of reinforcement learning, we don't need to worry about data self at all. Don't need to worry about training at all. Training is not at all needed in reinforcement learning. So in that aspect, we don't need to worry about even data set. Data set is not at all needed with respect to reinforcement learning. With respect to the problem domain, reinforcement learning algorithms will learn something according to the punishment and rewards given. Reinforcement learning models can be generated. So from the models, we can go for predictions. So in that aspect, a lot of research is going on in reinforcement learning. So if you get into artificial intelligence, always you can look for reinforcement learning algorithms, which can be applied to any application in which data set is a very big problem. So in that aspect, reinforcement learning can be incorporated to any application in which data set is not available. So if you want to get into research, you can always look for reinforcement learning algorithms. So as I mentioned, with respect to supervised and unsupervised learning algorithms, we need data set. Deep learning algorithms have evolved so much. It is because of data sets available in different applications, different field of interest. Similarly, we have computing facilities. Either we can have our own computing facilities, or we can go for cloud architectures by which we can run our algorithms for very huge data sets. So in that aspect, deep learning algorithms and machine learning algorithms have evolved over last 10 years. But this is not applicable for all the applications or all the field of interest. If you consider medical field, over 1 decade, we are able to get large amount of data from different organizations by which we are able to run deep learning algorithms. But even in so many organs, with respect to different medical imaging modalities, we are struggling to get data set. So because of that, we are not able to proceed further in the case of interpreting intelligence to the algorithms. So that is one aspect whenever we need to consider when we think about artificial intelligence for medical image analysis. So in that aspect, just I want to get into these topics today. These slides I have taken from Daniel Neil and Shyama Nagarajan team. So my acknowledgement to those two teams. So artificial intelligence can be implemented to medical image analysis, but the big issue we have there is amount of data which is available with respect to different diseases, different medical imaging modalities. We have data augmentation techniques by which even less amount of images can be augmented further so that we can go for effective training. But even in certain cases, we are struggling for training because of less number of images and the ground truths available. So advantage of machine learning to incorporate artificial intelligence is we can retain information, become smarter over time. Machine is not susceptible to sleep deprivation, distractions, information overload, and short-term memory loss. So here I have skipped these definitions and other applications of artificial intelligence because you might have heard about different definitions, different applications of AI over last 4 days. So just directly I want to get into artificial intelligence for medical image analysis. If we use artificial intelligence for medical image analysis, we can retain information with respect to particular patient over the years. So data can be collected even for 10 years and it can be kept in the memory, kept in the database. So whenever one doctor wants to analyze, wants to know about the history of symptoms or history of diseases with respect to one person, then always it is possible. It is possible if we go for artificial intelligence. So, but if we go for other options, so one medical expert asked, one doctor has to refer so many documents to know about the medical history of particular patient. But that can be completely avoided if you go for machine learning algorithms by which artificial intelligence can be incorporated to the medical data. So that is what this can retain information. We can retain information. And with respect to data, successive data which is gathered over time, machine can become more smarter over the years. So based on learning, with respect to different amount of data which is given to one machine learning model over time, the learning becomes better. Learning becomes better if it is classification task or if it is a segmentation task. Accuracy will improve greatly because of more amount of data which is collected and given to the machine learning model. So over time, if we use machine learning algorithms or deep learning algorithms for medical image analysis, those models will become even smarter with respect to more amount of data and more symptoms, features related to the symptoms given to the machine learning model. Then machine is not susceptible to sleep deprivation. It is related to the lack of medical experts. That is a number of medical experts for the huge population in our country. So always we don't find radiologists, we don't find medical experts for particular diseases. So they are overloaded actually. So, but as far as machine learning algorithms are machine loaded with artificial intelligence is concerned, those machines will not get tired. We can give data at any point of time. So we will be able to get the predictions and the outputs at any point of time. So we don't need to worry about overloading, sleep deprivation, and so on. There will not be distractions because of algorithms loaded in the machines. Then information overload. So even sometimes if medical experts are overloaded with large amount of information, then they will get confused. You might have heard this type of examples over last 2 years with COVID pandemic. So even with large amount of information overload, medical expert will get distracted, and they will not be able to decide which is correct, which is wrong. But that can be avoided if you go for artificial intelligence. Just by making simple changes to the programs, always we can leave the unwanted data, otherwise data which is redundant. Then this short-term memory loss, this is also important factor with respect to human experts, medical experts. If they are not able to recall particular treatment for even small amount of time, then it is going to be big loss to the patients. But that sort of problem is not at all happening with respect to artificial intelligence algorithms which are taught to the machines. With respect to artificial intelligence algorithms in medical imaging field, we have two branches. One is called virtual branch, another one is called physical branch. This physical branch is related to robotic surgery and so on. In the case of virtual branch, it is related to analyzing images from different medical imaging modalities. So with respect to analyzing images, it can be either classification of tumors or classification of diseases or segmentation of regions or even enhancement by deep learning networks and so on. So virtual branch, which is dealing with images from medical imaging modalities. As far as physical branch is concerned, that is related to robotic surgery and so on. In the case of virtual branch, it is also related to data which has been collected over the years, by which this telemetry related treatment prediction, that is also coming under virtual branch. So we go for this type of artificial intelligence branches because of highly repetitive work. Most of the factors which are based on Indian conditions or underdeveloped countries, based on underdeveloped countries. So highly repetitive work. So we have less human manpower in medical field. Then by using large amount of data which is collected over different geographical locations and different patients, we can empower doctors. So doctors can learn quickly if they get a lot of predictions, lot of knowledge from the artificial intelligence systems. So this AI helps to deliver faster and more accurate diagnosis. But one thing we need to understand is these deep learning devices will not replace clinicians. Even if we consider artificial intelligence devices cannot replace clinicians or medical experts. At the end of the day, final call should be from one doctor only. Even though we can get a lot of predictions, a lot of treatment planning from the artificial intelligence systems, but at the end of the day, doctor has to say yes to deploy something or to implement something. So that is the major factor which we cannot refuse. So we can augment the professionals. Professionals can be augmented by different images, augment the professionals, offering them expertise and assistance. So this is one important factor because nowadays people who are completing various degrees in medical field, they need to go for internships for 2 years, 3 years to get a lot of idea from the patients, from the senior medical experts. But this cannot be avoided. It is very much needed. But at the same time, those junior medical experts can be assisted by artificial intelligence systems, by which their learning will be very fast and they can get a lot of case studies, lot of scenarios from the artificial AI systems. So that sort of applications are available. That sort of systems are available nowadays, so that learning will be very fast because of this AI-based systems. These AI-based systems replace medical personnel and staffing in medical facilities, particularly in administrative functions. So, if you consider this medical facility allotment, so how many beds are there? After 10 days, how the particular pandemic will progress. So after 10 days or 15 days, how many beds will be needed? So these type of predictions are possible by AI algorithms. So that AI algorithms. So in that case, people who are required to carry out this type of tasks will be replaced by AI-based algorithms. So this already we have experienced in the pandemic time, because we might have seen a lot of research papers based on third wave, second wave, and so on. So when the second wave will peak and when it will decrease, all the data we got in appropriate times. So accordingly, a lot of decisions were made by the governments. What about yes? Can you mute your mic? Are you talking to me? Okay. So machine learning algorithms or AI algorithms can give predictions about the disease progress over time, so that even governments can be alerted regarding the medical facilities which are required at particular point of time. So this happened in the last year. Yeah, can you hear me?
Yes, sir. Yes, sir.
Yeah. I don't know. So according to the predictions, even government was ready with the medical facilities, so that we were able to save a lot of human lives. So in that aspect, with respect to administrative functions, AI algorithms can replace the experts or persons. Then managing waiting times and automating scheduling. Even with respect to symptoms, AI algorithms can predict that particular patient should be inpatient or he can be outpatient. So that type of predictions also possible by using AI algorithms. So it will reduce managing wait times, and it will also automate uh, the facilities, allotment of facilities in particular hospital. So as I told, deep learning devices or artificial intelligence devices cannot replace human beings, at least for another decade. But even after 1 or 2 decades, even experts may be replaced by AI algorithms. Even we will start believing AI algorithms than human experts. So this is a virtual branch with respect to artificial intelligence. While discussing with different patients, these AI algorithms can gather symptoms from the patients, past history from the patients, then that can be stored in the database. Similarly, past data and vital parameters. So important vital parameters, that is what you can observe here. Vital parameters can be observed. Those vital parameters can be saved. Here, whatever the input given by the patient, input from the patient can be saved in the database. Here, vital parameters can be saved in the database, which can be processed by AI algorithms. Similarly, we have some more sensors here. So a lot of data can be collected from the human body. Those vital parameters can be saved further. This is colonoscopy. We used to call endoscopy. So the images which are gathered using endoscopy can also be processed by artificial intelligence algorithms. With respect to this endoscopy, as far as endoscopy is concerned, large amount of continuous video will be collected by the camera, which is available at the end of the probe. So that video can be closely monitored by AI algorithms. As far as medical expert is concerned, medical expert will watch the video for a very small amount of time. Always there is a possibility of missing out the details, otherwise abnormal regions in the esophagus, otherwise in the region of interest. There is a chance. So, but that can be avoided if you go for artificial intelligence algorithms, because artificial intelligence algorithms will analyze each and every frame in that video, so that we have less chance of missing out any frame in the entire video. To avoid that only, now we have capsule endoscopies. We have camera in the capsule. So whenever that capsule is swallowed by the patient, then it is called a capsule. That is, camera in the capsule will capture a lot of images. Even if you say 2 images per second, then that capsule will be inside the human body for almost 8 hours. So 2 images per second, if you consider images taken for 8 hours, then we will have thousands of images which are to be processed by the medical expert, but it is very laborious task. So in that aspect, we can go for artificial intelligence, by which the images which are to be processed, which are to be analyzed by the medical expert can be selected, or even if we have AI algorithms which are able to go for disease classification, segmentation, then we can use those algorithms by which particular frames taken by the capsule endoscopy can be analyzed. So these are all coming under virtual branch. All the imaging modalities, images which can be analyzed by artificial intelligence algorithms is coming under the virtual branch. As far as these algorithms are concerned, these algorithms are coming under unsupervised case, supervised case, and reinforcement case. Now a lot of research is going on in reinforcement case. So what are the benefits of AI in medical field? So clinical decision making not only based on one medical expert, it can be done based on so many medical experts even all over the world. But as far as clinical pathology is concerned, it may change with respect to geographical regions. Even that factor can also be incorporated into artificial intelligence algorithms, AI algorithms. Accordingly, clinical decision making can change. You might have observed the same over the last 2 years. Whatever the treatment suggested in Western countries, those treatments were not that much successful in our country. There were a lot of changes with respect to the treatment and other steps taken by the government. So those aspects can also be incorporated into artificial intelligence algorithms, AI algorithms. Accordingly, decision making can be made adaptive. So that is possible in AI. Replace human judgment in certain functional areas of healthcare, particularly in radiology. So because of laborious task, even if you consider the number of radiologists present in our country, actually very less in number, very less in number. So in that case, if one radiologist has to analyze large number of images and they have to give reports on more images, always there is a possibility of human error that can be reduced by using AI algorithms, by using deep learning based classification algorithms and segmentation algorithms. Then important factor for using AI algorithm is up-to-date medical information from journals, textbooks, and clinical practices. Because of multimedia technologies, any treatment, any planning, which can be communicated to other medical experts instantly, so that immediate update is possible if you use artificial AI algorithms for treatment planning and clinical pathology and medical diagnosis. Then experienced versus trust clinician. This is what I told. Even trust clinicians can get a lot of idea because of artificial intelligence algorithms, because in the database, information about different diseases all over the world can be collected, and which can be learned by trust clinicians. So learning is fast and quick if we go with AI algorithms in medical field. Then 24/7 availability of expert. So anytime you can feed input to AI algorithms, you can get output at any time. So that is another advantage of AI algorithms. Then early diagnosis is possible by using AI algorithm, so that even casualties can be reduced. So here, this is a deep learning network which analyzes different symptoms, different features with respect to abnormal regions, with respect to different diseases, so that diagnosis is possible. Then this is skin cancer classification. Even now, skin cancer classification, which is possible by using even mobile phones, you can capture images of skin, abnormal region in the skin. Those images can be sent to the cloud, in which deep learning algorithms, which have been trained with respect to very big database, can work on the input images given by the mobile phone camera. Then immediately the deep learning algorithm from the cloud will give classification results to the mobile app, so that one can know whether the abnormal region present in the skin is related, is cancer or non-cancer or something else. So that is possible by AI algorithms using mobile apps. What are the other advantages by using AI algorithms? Prediction of outcome of the disease as well as treatment, both are possible by using AI algorithms. Even feedback of treatment can also be incorporated. So since we go in terms of software, even feedback can also be incorporated. If you look at the same with respect to the documents, otherwise day-to-day activities done by the hospitals in our localities, our regions, if any other doctor wants to give treatment, then he has to refer large amount of document, more documents. Then sometimes there is a possibility of missing out the documents, so that treatment may change with respect to the doctors. Even feedback given at particular point of time by the patient to one medical expert may not be known to another medical expert. So in that case, there will be a discontinuity with respect to treatment. So these things can be avoided if we go with artificial intelligence algorithms, because all the medical history can be kept in the database. Even treatment and feedback can also be kept in the database. So whenever any other medical expert wants to give treatment to the same patient, and he can see all the data from the database, and subsequently successive treatment is possible. So that is what another advantage of AI algorithms. Feedback on treatment can also be included with respect to the data available in the database. It will help the medical expert who is going to treat the patient further. Reinforce non-pharmacological management. Reinforce non-pharmacological management with respect to drug delivery, drug predictions, and so on. We can go for reinforcement algorithms by which successful drugs administration is possible. Reduce diagnostic and therapeutic errors by using AI algorithms. Diagnostic errors and treatment therapeutic errors can be reduced by AI algorithms. Increase the patient safety and huge cost savings associated with use of AI. So here, whenever we go with AI algorithms, then always patient data should be secured from malicious access. So in that way also, patient safety is patient data safety is given more importance. Meanwhile, because of the prediction and other knowledge sharing by the artificial intelligence algorithms, medical experts will be directed in the right direction, so that most of the time they will end up with the correct treatment. Then huge cost savings associated with the use of AI. One example is the pandemic. With respect to the predictions with respect to second wave and third wave, even government was fully equipped with a lot of medical facilities. So because of that, so many lives were saved. That is one thing. Another aspect is this initial screening is possible by using artificial intelligence algorithms. Even one patient can know whether he needs inpatient treatment, or just he has to go to the hospital and he can come back within 2 hours, 3 hours. In that way, artificial intelligence algorithms can give initial idea about the treatment to be carried out for certain symptoms or the medical history of particular patient. So it will lead to huge cost savings, not only with respect to treatment, with respect to administrative stops also. Then AI system extracts useful information from a large patient population. This is another aspect. With respect to knowledge about particular disease can be gathered from large population, and it can be kept in the database. So useful analysis is always possible. Assist making real-time inferences for health risk alert and health outcome prediction. So if a particular one pandemic is say breaking out, then this machine learning algorithms or artificial intelligence systems can predict the growth of this pandemic over time and break off some other pandemic because of this pandemic is also possible by AI systems. So health risk alert and other things predictions are always possible by using AI systems. The learning and self-correcting abilities to improve its accuracy based on feedback. So if any major correction with respect to particular treatment is there, which is happening in other part of the world, then it can be known by the expert because of these AI algorithms, then which can be immediately corrected. If it is not there, then always one medical expert will not have the possibility of coming to know about the error in the treatment. But when we go with the AI algorithms, always adaptability will be there. Learning and self-correcting abilities will be there with respect to the algorithms, whatever we write. This is physical branch, artificial intelligence in physical branch. So we use physical objects, nothing but sensors, medical devices, then sophisticated robots. One example is carrying robots. So if the patient is not able to move from one place to another place, we can have robots to serve the patient, to always check the vital parameters of the patient. So we can use sensors with respect to different vital parameters of one patient. So that is also coming under physical branch. Physical branch, we have so many sophisticated wearable devices nowadays by which different parameters, different vital parameters of one patient can be observed and which can be delivered to the doctor who is sitting in some other place. So these are all coming under physical branch. Then robotic surgery is also coming under physical branch. Robotic surgeries you might have heard about. So that is also coming under physical branch. So why we need to spend a lot of billions of dollars in healthcare, in particularly for artificial intelligence algorithms in healthcare? It is because increasing individual healthcare expenses, larger geriatric population, people who are suffering from diseases, and people old age people who are suffering from diseases that is increasing all over the world. Then imbalance between health workforce and patients. This is one major factor in underdeveloped countries. Increasing global healthcare expenditure. So this is another major factor. Then continuous shortage of nursing and technician staff. So the simple task, that is the task in which no intelligence is needed, can be done by robots. So there we can implement simple intelligence by which those robots can serve to so many patients in around the world. That is another factor. Continuous shortage of nursing and technician staff. The number of vacancies for nurses will be 1.2 million by 2020. This is old data. AI is will help medical practitioners efficiently to achieve their tasks with the minimal human intervention. Minimal human intervention, a critical factor in meeting increasing patient demand. So here, all the data can be given to artificial intelligence algorithms, but at the end, whatever the predictions suggested by the algorithms, one doctor can take a final call. Accordingly, the remaining steps can be decided in treatment, otherwise diagnostic procedures. So AI algorithms will improve accuracy of diagnosis, prognosis, and risk prediction. Reduce medication errors and adverse events, model and prevent spread of hospital acute infections, because one AI algorithm can tell that whether the patient is needed hospitalization or he can sit in the home and take pills from the advice of medical experts. So in that way, predictions are possible by using AI algorithms. So this hospital acquired infections can be avoided if we go for AI based diagnosis. Optimize hospital processes such as resource allocation and patient inflow. We can predict whether the disease will increase over the time or it will surge. So accordingly, resource allocation can be effectively done by using AI algorithms. Identify patient subgroups for personalized and precision medicine. So that is also possible. Discover new medical knowledge, clinical guidelines, best practices because of the data which is collected all over the world from different top hospitals. Then automate deduction of relevant findings in pathology, radiology, etc. using deep learning algorithms and so on. So this is one example of risk prediction. With respect to various patients, this AI algorithms can predict that whether the patient is in the age group of 20 needs hospitalization or he can sit in the home, undertakes treatment. If the patient age is for the same disease, the patient age is 60 years, then whether he needs hospitalization or he should be in ICU. One example is we experienced that people who suffered by COVID in the age group of more than 60 or 70 should be hospitalized immediately. So that was the experience we had in the last 2 years. So in that, those type of predictions are possible by using AI algorithms. So one patient who suffered by particular disease can open one AI app and he can feed the inputs, age and other symptoms with respect to particular disease. Then the AI algorithm will tell that you need hospitalization immediately. Accordingly, this patient can decide whether he has to go to the hospital or he can sit in the home and take treatment. So these type of predictions are possible by using AI algorithms. We were given a lot of guidelines in the last 2 years. But so many people did not know about those guidelines. So because of that, we suffered a lot. But those things can be reduced if you go for AI-based applications in our mobiles, and those AI-based applications can give predictions whether hospitalization is needed or outpatient treatment is needed or ICU resource should be allotted to the patient or not. So in that way, here different factors have been listed out. So according to the symptoms and other factors, one AI system can decide the risk. So these are all the features or symptoms with respect to the diseases. So accordingly, risk prediction and visualization is always possible. So hospital resources can be effectively utilized whether particular patient needs oxygen support or not. Those type of predictions are possible by using AI algorithms. Because of lack of man force, we were struggling a lot to get proper advices and predictions. Then to analyze these pathology images, it is of very big size actually in terms of GBs and all. If you want to analyze this pathology, clinical pathology images, then one expert has to spend lot of time to observe the abnormalities present in the tissues or cells. So if the expert is getting tired, if the expert analyzes so many images in one day, then always there is a possibility of human error, but which can be reduced by using AI-based algorithms. In the case of clinical pathology, that is digital pathology, this AI algorithms can be effectively used to analyze each and every region of this pathology image. Accordingly, effective tissue analysis, cell analysis can be done, and prediction or classification related to tumor and other things can be done by AI systems. So one small region of this clinical pathology, digital pathology image is expanded and it is shown. Similarly, very tiny images can be processed by AI algorithms. Meanwhile, it is difficult by the human experts. So these are the applications which are effectively done by AI algorithms in the medical field. Some of the case studies here you can find by using AI algorithms. So AI powered multipurpose platform for medical image analysis. So here not only we can have deep learning algorithms to analyze medical images, we can have different, that is history of diseases all over the world can be collected and which can be kept in the database, and even treatment and treatment planning and other things can also be kept in the same AI algorithm. So we can have a package like AI system which can deliver the complete data about particular disease, about particular patient. So AI powered multi-purpose platform, that is possible. So even one AI powered system can cover so many diseases, even with respect to particular patient. So this is a cloud-based AI application. Now people are moving towards this sort of applications. Over the years, always we are looking for high-powered devices to handle large amount of data, to process large amount of data. So we relied on cloud platforms to process large amount of data. Now people are looking for this type of application, that is front end. Front end is in the sense mobile app which just observes the input images, which just takes the input, and the input will be delivered to the cloud in which deep learning algorithms are available, or AI algorithms are available. So just the input is given to the cloud framework. There already deep learning networks and other machine learning algorithms have been trained on very big data sets. So AI system is ready to analyze the input given by the mobile app. Whatever the analysis done, then immediately it will be delivered back to the mobile app, so that one end user can see the analysis or any other data from the cloud storage. So now so many applications are based on this type of cloud-based system. So in the mobile, as far as mobile is concerned, or any other digital gadget is concerned, which can be used as just capturing device, image capturing device, or the device which is collecting only input data or features, which is forwarded to the cloud framework, cloud system. There everything is processed, and the data or final output is delivered to mobile back. So that type of applications now are worked out by different startups and different research groups. So implementing AI algorithms for medical image analysis is all about extracting features and how to assess those features by which model tuning is effectively carried out. Once model tuning is done, then it can be machine learning model or deep learning model can be deployed, and it can be integrated to one AI system, so that historical data can be collected and it can be kept in the system. So this is machine learning flow. This is was machine learning deployment. Once it is done, then it will be incorporated into a cloud framework or any other systems. Then in the front end, data can be collected and it can be given to the remote system, enterprise system, so that it can be processed effectively. So your good news is that you are perfectly healthy. The bad news is that my algorithms predict you will be dead in 2 days. So this is what the doubts always we have whenever we go for algorithms related to medical opinions and so on. But in one or another 2 decades, then we will start believing AI algorithms than medical experts. So over the talk, I have told that it is all about feature extraction. How features are extracted so that machine learning algorithms can be tuned. Otherwise, how features can be extracted by deep learning algorithms so that deep learning algorithms can be tuned to our requirement. Even if you consider reinforcement algorithms will work on the application scenario by which learning will be done. So with respect to that, I want to give a small demo on classification learner application in MATLAB. Can you see my MATLAB screen? Can you see my MATLAB screen?
Yes, sir.
Yeah, thank you. So here my plan is I want to show how the data, how features can be extracted from the set of images. Then how can we write Excel file or CSV file so that which can be taken by this classification learner app so that machine learning can be implemented. So that is what the plan. So this is classification learner application, which is ODAN. So we can download and which can be installed with the MATLAB version, licensed version or any other version. So this is what classification learner. Just let me open it. Okay, so it is getting opened. Then this is small demo on classification learner. If you have CSV file or Excel file, then you can easily implement machine learning algorithms to your Excel file or CSV file. Then you can run a lot of machine learning algorithms in simple steps. So that's what I want to give demo now. So this is one example. Actually, this is brain tumor classification MATLAB code. So here the region of interest is separated from the background. Region of interest is separated from the background. In my data set, I have 30 odd images. From the 30, each and every image I have abnormal region. So from the abnormal regions, I have to extract features. Then those features should be arranged as an Excel file. Then that Excel file should be given to classification learner app so that different machine learning algorithms can be run on the features. That is what the idea. And this is what the data set. So brain images, MRI images with abnormal regions. So from these images, I have to separate the abnormal region alone. Then I can go for gray level co-occurrence matrix. It is GLCM. One technique by which texture characteristics can be observed from the abnormal regions, like homogeneity, entropy, correlation coefficient, and other features can be extracted from the abnormal region, and those values can be kept as a CSV file or Excel file. Then it can be given to machine learning algorithm. So as far as machine learning algorithm is concerned, input is features. From the images, we have to extract features. Those features should be given as input to the machine learning algorithm. So the existing machine learning model will be tuned to the given data features with the target if it is supervised learning. If it is unsupervised learning, without target. So that is what the idea. This is what the image data set. From this image data set, what it do is I separate the region of interest by using FCM clustering. So this is what FCM clustering, so that specific abnormal region can be separated. That is, one region can be separated. From the region, I go for gray level co-occurrence matrix. So that I can separate features. So V1 to V12, 12 features are separated, and those features are available in this matrix, feature matrix. Then that is written as Excel file. That is what XLS write. I run this program for 30 odd images so that I will have 30 feature vectors. 30 feature vectors with the 12 columns. 12 columns because I extract 12 features for each image. Since I have 30 images, there will be 30 feature vectors. since I go for 12 features, there will be 12 columns. Then the 13th column will be the target column. Target column in the sense ground truth, tumor or non-tumor in that way. So that from the ground truth, I have to attach the target column. Then that is what written as Excel file here. Excel file to particular location. That is what the idea. So just let me run for one image. I don't want to go for more images, only one image. Yeah, my code is running. Please. So this is what the input image, which is converted into gray. It is actually a color image, which is converted into gray. Then I go for FCM clustering, Fuzzy Siemens clustering, so that I consider only abnormal region by using this into BWD thresholding concept. So from that, I will extract features, that is area, homogeneity, energy, and so on. Correlation coefficient and other parameters with respect to GLCM, gray level co-occurrence matrix. So abnormal region. Yeah, this is what the abnormal region, which is separated from the original image. Say this is what the image in which abnormal region is separated. Here I have gone for pseudo coloring so that abnormal region is differentiated from the background. From this segmented image, I need to extract features. Those features are available in this feature matrix, in this variable name, feature mat. See here. If I open this, you can see it is 1 row, 12 columns. So I have 12 features. 12 features for one image. Similarly, I will run this program for 30 odd images. So I will get 30 rows and 12 columns. Then in the 13th row, I will go for my supervised, that is target for supervised learning. So once it is done for 30 odd images, then I will write that as an Excel file. That is what this line, last line. Once it is done, then I will have my Excel file here. Excel file, say I have saved those Excel files here. I can take this Excel file in my classification learner app. So this is what classification learner app, which is very simple. You can run multiple algorithms with very less time. Even you can observe a lot of results. If you want to write a paper, this is very much useful. So you have to start a new session. So go for the new session. I want to load my Excel file. So from file. So I have to load my Excel file. So brain tumor 1. It is one Excel file. Just I want to load. So here you can observe. I have 1 to 13. Then this last one is target. So I can import my selection now. So whatever the data available, see here. Small changes I have made. So only it has 13 features. So 14th column is target column. So for training, as far as input features are concerned, those features are also called predictors. So only predictors are selected. Last column is target column. So it is not selected because we have to designate these are the features. And I have to designate the last one as target. So that is what shown here. That is what shown in this pop-up window. Now I go for even cross validation, 5 cross validation or 10 cross validation. In that way, even I can select. Now I am starting my session. So what I did there is I selected my Excel file. From the Excel file, I imported my data. From the data, I selected the features. Then target was not selected. then now I have imported completely to my classification learner app. Classification learner app. Now you can see my data here. It is a scatter plot. So as far as this scatter plot is concerned, it is drawn between, say, variable name 1 and variable name 2. So between two variables, this scatter plot is done. With respect to other variable also, you can go for the scatter plot. So two colors you have, it is because I have two output classes. So with respect to output classes, you can analyze inputs here, whether the inputs are leading to two separate output classes or overlapping or not. In that way, you can analyze your inputs so that any input which is not helping for classification can be removed by using this scatter plot. Okay, so different features can be analyzed. Variable 5 and 2. As far as variable 5 and 2 are concerned, variable 5 and 2 are somewhat leading to these two output classes. See here. Here I have one output class, that is blue color. Then here I have another output class. So variable 5 and 2, by using variable 5 and 2, I am able to separate two classes somehow, not completely. But if I consider some other classes, see here, it is totally confusing. Variable 9 and variable 2. I'm not able to separate two classes here because I have a lot of, that is two classes here. I have two classes here also. So in that way, some features are not contributing enough to the classification. In the that can be identified by using this scatter plot. Accordingly, those features can be removed from training. That is what the option available here. See here, you have feature selection. If you see the small window, I can select the features. I have 13 features. I can select only 12 or 11. So I have disabled two features. Okay, once it is done, then I can go for my. See here, you can observe that out of 13, I have selected only 11. I have selected only 11. Once features are selected, I can go for different machine learning algorithms here. See here, decision trees, discriminant analysis, logistic regression, support vector machine. In support vector machine also, I have all different techniques, different variations. Then I have, this is KNN and the variations. Then this is ensemble learning. Ensemble learning. In that way, I can select so many machine learning algorithms, and I can go for even comparative analysis once with respect to all these algorithms. So what I have done is I have selected only one KNN with respect to 11 features. So now I am going for training. This is training. Okay. With respect to KNN, here K value is how many neighbors. K value is the parameter in KNN. So I can change K value here. That is parameters. We used to call sometimes hyperparameters. So parameters of machine learning algorithms can be adjusted using this tab. That is this advanced tab. Then now I go for training. So training is happening now. If the data is less and your system is capable of doing it with less time, then it will do immediately. So what I have done is I have imported my data. I analyze my data using scatter plot. Then I select features. Out of 13 features, I have selected only 11. Now I have selected one algorithm, KNN algorithm. Now I am training my model for the input given. So training is going on. Once it is done, you can have your confusion matrix here. Confusion matrix, ROC curve, and parallel coordinator plot. All these plots you can have, by which you can write your paper comfortably. So KNN, which is with respect to centroids, you have to calculate Euclidean distance with respect to all the values present. Since we have 11 features and 20 feature vectors, Euclidean distance should be calculated with respect to all the features. So it is taking time. While running first time, more time will be taken. Once it is over, then you can run some other algorithms with less time. Any doubts on this classification learner app? So this can be installed as an add-on with the MATLAB. If you have Excel file with respect to your data set, just like that, it can be called, and you can run so many machine learning algorithms on the input data, so that you can get enough results to publish conference paper or even journal paper. Once training is done, you can export this model as a MATLAB code, and even you can go for prediction with respect to unseen data, otherwise new data. For the new data, always you can go for prediction by using this train model. Once training is over, you can export the model. You can export the model. Then by using that model, always you can go for prediction for the new data. So in that way, if you want to write journal paper or conference paper, it can be easily done by using this classification learner app. Thing is, you have to construct your Excel file or CSV file. From the file, always it will be easy to go for machine learning algorithms, training as well as prediction. Let it go for the training. Any doubts? Any queries? If you have any queries, you can ask me. Meanwhile, this training will be over so that I can proceed further. Any queries from the participants?
Hello, sir.
Yes.
Yeah, sir. Thanks for the nice explanation. Sir, I have a generic query. It is said that machine learning algorithm learns with time, but we have to update the data, right? By itself, it is not possible.
Machine learning algorithm, for machine learning algorithms, we need to extract features.
Yeah. And
deep
we
learning
need
algorithms will extract features on their own based on the filters we use.
Okay. Okay, sir.
Yeah. So that's what. If you want to go for machine learning algorithms, then you need to work on feature extraction. So features are key for learning. If you go for appropriate features, learning will also be good. If your features are irrelevant or redundant, then machine learning will be bad. Learning will be bad. It will not be as expected. So that is what the problem. So we have separate concept known as feature engineering. Then feature processing is also separate topic. Feature pre-processing is also separate concept. So in which you need to work a lot to make your data ready for training. If your data is appropriate, then only learning will be successful. Accordingly, prediction will also be successful. So as far as this KNN is concerned, you can see accuracy is 65%. Once this training is done, I can go for any other model, linear SVM. It will happen with less time. This training will go fast. So 65%. Let me go for this ensemble learning, all ensemble learnings. So I can select all. So see, now all the algorithms will run one by one. Accordingly, I will get results. So by using this data itself, you can go for comparison tables. 70% I get by using this subspace discriminant analysis. So in that way, you can go for your comparative analysis. Then let me go for this linear discriminant analysis. Linear discriminant analysis for which the data whatever I have given is not supported, so it is not running. So logistic regression I can go. Logistic regression. So there I get very poor percentage. So here ensemble method with the subspace discriminant is giving 70%. So here you can observe this is what predictions. So you have correct prediction and wrong prediction. If you want to see only correct prediction, these are all correct predictions, and these are all wrong predictions. Wrong predictions. Then I can go for confusion matrix here. So this is what the confusion matrix, and this is what the ROC curve. This is all about with respect to training data. This is ROC curve. Then this is parallel coordinator plot. So wherever if the predictions are not correct, those predictions are represented by this cross mark. That's what you can observe. So in that way, you can have a lot of data, lot of plots and other data to write a paper. So here, see here, I have run so many algorithms here. KNN, SVM, ensemble method, different ensemble methods, and then logistic regression. Even with respect to different all SVMs, I can run. So most of the algorithms are giving around 65. Now what I can do is I can go for feature selection. That is, I can include 2 more features. Whatever I left, I can include. Now I have 13 by 13 features. For 13 by 13 features, I can run this my ensemble, all ensemble learning methods. So if I go for 11 features, what is the accuracy I get? If I go for say 13 features, what is the accuracy I get? So I get same accuracy as that of 11 features. Now I can say that those 2 features are not that much important. Those type of analysis, that type of analysis is also possible by using this classification learner app. See here how many algorithms I have run, I have simulated. Accordingly, I can go for comparative analysis. Similarly, this confusion matrix ROC curve with respect to particular algorithm. See here, this is what the maximum percentage. So this is the confusion matrix. This is the ROC curve. This is parallel plot. I got less number of incorrect predictions. So once it is done, I can export the model by clicking export compact model. So that I can export the model, then I can go for a prediction by using that model. Then whatever the training I have done, the same code can be exported by using generate code. So whatever the training done, whatever the cross validation done, then whatever the accuracy which has been calculated, all this the code for all these steps can be saved by using this generate code. If I go for generate code, then this is what the entire code by which whatever I executed, you can run again. So this is generate code. Now by importing the model, what you can do is you can go for prediction. Export compact model. If you go for export compact model, then it will be saved as a trained model, or you can give some other name also. So to this model, you can give a new data. You can give a prediction data so that it will predict. For that, you can calculate prediction accuracy, and which can be included in your paper. Okay, so this is what classification learner app. If you have any doubts in this application, MATLAB app, you can ask me so that I will complete in another 2 minutes. So this is very comfortable tool. If you spend just 1 or 2 hours, then you can come to know how to use this classification learner app for machine learning applications. Then you can easily write papers, conference papers, journal papers based on the results you observe from this classification learner app. Okay. Any doubts you can ask me with respect to this app so that I will wind up. Any other queries? You can ask me. Any other doubts?
Participants, if you are having any questions, you can ask. Expert is waiting. Participants, if there is no questions, I think we can wind up this session. Thank you, Vijay sir. Now we will begin our valediction. Our dean also has joined. You discuss with our dean, Dr. M.V. Nageshwar Rao sir.
Vijay, how are you?
Sir, good evening, sir. Good evening.
Good evening,
sir.
good evening.
Jagan Naveen, sir. Good evening. Happy to see you all, sir.
Yeah.
I'm very happy that I can deliver a lecture for my institution. I can probably say.
At least we have got an opportunity through this FDP to listen to you.
Yes, sir. Thank you, sir. Thank you, sir. Good evening, sir. Jagan, sir. Good evening.
He is not yet connected his audio system, I think.
Yeah.
I'm connected, sir. Good evening, sir. Sir, good
Yeah,
evening.
very good evening, sir. Happy to hear from you, sir.
Sir.
How is your children, Vijay?
Fine, sir. Everyone is fine.
Fine, going fine. Huh?
Yes, I think, sir, shall we begin our valediction, sir?
Yeah, go ahead, sir. Go ahead.
Yes, sir. Yes, sir. Madam, Durga ma'am.
Sir.
I think valediction we can begin, madam. You just begin with your speech, madam.
Okay,
Please.
sir. Good evening, everyone. I thank the resource person for accepting our invitation and delivering his lecture. Vijayarajan sir, thank you very much, sir, for sharing your knowledge with all our participants. And I welcome the resource person and our Dean Academics, our resource person, Dr. Vijayarajan sir, our GMRIT Institute of Technology Professor and Associate Dean Academics, Dr. M.V. Nageshwar sir, and HOD of EC Department, Dr. V. Jagannaveen sir, and also HOD of Sri Sairam Institute and other faculty members and coordinators of the workshop and all the people who are involved in this and all the participants. I am very thankful to you for your cooperation for successful completion of this workshop. I welcome all of you to this valedictory function in online mode. Now I request Dr. Jagannaveen sir to address the participants and resource persons.
Madam, my voice is audible, madam?
Yeah.
Yes, sir.
Yes, sir. Thank you, madam. Good evening to one and all. We welcome the dignitaries of SSIT, Chairman Garu, Director Garu, Principal Garu, and the dignitaries of GMRIT, Director Garu, Principal and Dean Academics, and the head of the Department of SSIT, and all the faculty members of GMRIT and SSIT, and participants to welcome this validatory function. We thank all the participants to join in this 5-day FDP program on advanced signal processing communications using artificial intelligence and machine learning techniques, jointly organized by GMR Institute of Technology and Sri Sairam Institute of Technology, Chennai. We thank all the resource persons spending their valuable time to deliver the contents in these sessions. I thank each and individual person, resource person, Dr. S. Rajarajan, delivered a talk on device level artificial intelligence for 5G networks. Dr. S. Murugan sir, he delivered talk on web scraping. Dr. Geetama madam from GMRT, she delivered a talk on deep learning based medical image segmentation. Dr. R. Janaki madam, she delivered talk on machine learning technologies and wireless communications. Dr. Krishna Kishore, he delivered talk on fundamentals of artificial intelligence. And Dr. G. Saravan from SSIT delivered talk on advanced communications with artificial intelligence and machine learning techniques. Dr. Yogesh Mishra from GMRIT, he also delivered talk on sensor and sensing and processing techniques. Dr. V. Bharati from Sachibama Institute of Technology, she delivered talk on machine learning, trends, perspectives and prospects. Dr. V. J. K. Kishore Sonti from Sachibama Institute of Technology delivered talk on artificial intelligence, distributive technology, modern era. And Dr. R. Vijayarajan sir from VIT Chennai, he delivered talk on artificial intelligence for medical image analysis. So really we thank all the resource persons to give the valuable content to the participants. And we thank all the participants spending their valuable time in the evening from 4 to 7:30, 8 o'clock every day, these 5 days. We thank the management of GMRIT and SSIT Chennai to give this chance for conducting the FDP. And we also thank all the faculty members of the GMRIT and SSIT for their continuous support. And we thank the coordinators of this 5 days FDP program, Dr. Kannan Garu, Dr. Salve, Tamarai Salve, SSIT, Dr. J.V. Suman. And we thank the anchoring part taken care by Sivasankari Madam and Durga Kameshwar Madam. And the live stream sections will be taken care by Arun Shankar Garu, Kalyan Chakravarti and D.V. Ramana. So we thank all the members in both SSIT and GMRIT for their continuous support. Thank you one and all. Madam, thank you very much. And over to you.
Sir, okay, sir. Thank you very much, sir. Now I request our Associate Dean Academics, GMRIT, Dr. M.V. Nageswara, sir, to speak a few words.
Yeah, I can say good evening, one and all. At the outset, I would like to compliment and congratulate both the conveners, Dr. V. Jagannavan, Professor and HOD Department of PC, GMRIT, and Dr. S. Rajarajan, Dean Academics, SSIT, Chennai, for taking up a good topic on 5-day online faculty development program on advanced signal processing communications using AI and ML techniques. Nowadays, the AI and ML techniques is a buzzword. Everywhere we can use it. As in the inaugural function, I could sense that the strength registrations was very heavy, and there are several participations from various parts of the country. It indicates the strength of the topic, I can say that. And also AI and ML techniques can be used everywhere. It's not only limited to signal processing and communication. It is not only pertaining to any department or any branch. It can be used everywhere. So I can say that they have taken a good topic for this workshop, for this FDP. And on behalf of GMR Institute of Technology, I would like to express my sincere thanks to Sri Sai Ram Institute of Technology, Chennai management for accepting our request, and to collaborate with GMR Institute of Technology to take up the faculty development program. It may be a beginning, but several such activities will be taken up in future, and we'll have a long association with Sri Sai Ram Institute of Technology to take up these activities. And I have seen that many people are there, and several resource persons from Satyabama Institute of Technology, and also from VIT Chennai, from my friend Mr. Dr. R. Vijayarajan. And also there are faculty members who delivered the talks from GMRIT and also from Sai Ram Institute of Technology. I thank all of them. Even though the sections were conducted nicely in the evening session, leisurely for around 4 hours duration, but still I can say that it's a beginning. It's only a the all the expertise given by the resource persons. I am sure that it might have ignited the minds of the participants, and definitely they will take the insights provided by the resource persons, and they will take it forward to pursue their research and their enhance their academic career. So every function or every program will have a beginning and also an ending. So today we have come to the end of this closing of valediction of this workshop, this FDP program. So I hope these five-day deliberations will definitely will be useful, and I hope that there will be some takeaway for all the participants. If you have for improvement of these organizing these FDPs, if you have any participants can give their feedback. If always GMRIT believes that feedback only will be helpful for continuous improvement. Even though we did well, but definitely there will be some scope for improvement. So I request one of the participants at one or two any participants to give their valuable feedback for improving the conduct of workshops in future, and take up the collaborative activities with other uh, colleges also. With these few words, I don't want to take much of your time at the flag end of the day. So I thank you all for your participation, and thank the resource persons for their spending valuable time in sharing their expertise as participants, and thank both the management for giving the opportunity to the Department of EC. I thank all the conveners, coordinators involved in making up this FDPA success, and both side I thank the both managements also. Thank you all.
Thank you, sir. Now I request any of the participants can give the feedback.
Yes, good evening, all. I'm Zubeda from
Good evening.
ISL Engineering College. It was nice knowing about AI and machine learning. I was not aware of many things of AI, which I got to know from this conference. Thank you. And if in future
Thank you,
is
ma'am.
any conference, please add me up. Thank you again.
Yes, sure, ma'am. Sure, ma'am. Thank you. Any other participants want to express their views and give suggestions?
I would like to give my feedback. Can you allow me?
Yeah, why not, madam?
Sure,
We are
madam.
waiting
Sure,
for
madam.
that.
Thank you.
Yeah. So I am working as a selection grade professor in Government Polytechnic, Ratnagiri, Maharashtra. Whenever I heard about this FDP, I wanted to do it. First of all, I wanted to thankful to the GMRT College Dean and the team. I have saluted to the team because such a nice they are organized, such a organized this FDP. I wanted to characterize this FDP in three categories. First one is faculty. Whatever the faculty they have selected, that is wonderful. They know their job very well. They have given their lectures very clear, and representation will be in awesome way. Second thing is this while doing this FDP, I got very fun, just like a picnic only. One suggestion I wanted to do it that whatever sir, you are keeping the lectures of 2 hours each one. That is very. Please, can you reducing it small size, that is up to 1 hour or something, 1 hour and 30 minutes. 2 hours means it is very, we have to build up our stamina, sir. And I wish that you could do this FDP of 2 weeks, sir. Thank you very much. And please do FDP of 2 weeks, sir. Thank you for the all team. Thanks very much.
Sure, madam.
Thank you,
Definitely
Jyoti.
will.
Thank you,
Yeah.
Jyoti, ma'am, for giving your valuable feedback. And we appreciate your patience and interest towards learning. And in future also, please be a participant of our workshops and any other events, madam. Thank you very much for your suggestions. Any other participant want to give feedback?
Good evening to all.
Yeah.
Good evening, sir.
I am Dr. Sheikh Mahbub Basha, Professor in ECE, Gitanjali Institute of Science and Technology, Nellore, sir.
Oh,
Really, I am
good, sir.
very much thankful to the organizers, particularly Dr. V. Kanam sir. I got the information, and this is the third FDP I am participating from GMR Institute of Science and Technology. Really, these sessions are wonderful, and my colleagues are also almost 7 or 8 members have participated in this one. And it's a pleasant moment for me to appreciate the organizers as well as the resource persons. Really, they have contributed in depth in certain sessions. I have continuously heard the session of Dr. Rajarajan sir, and almost all the resource persons are very good. Really, I'm very much thankful to you, sir, the organizers and Dr. V. Kanam sir and other organizers. I am unable to remember all the names, but the information also being shared with the WhatsApp group regularly and continuously monitored. It is well and good. Thank you, sir. As I will cooperate, I will coincide with the opinion of Mrs. Jyoti Prahlad madam. If it is a 2-week session, it will be very great for us to improve our API score also. That will be, please look into this session. This is my session.
Sure, sir. We'll take up that part in next coming up FDPs.
Okay, sir. Thank you, sir. Thank you.
Thank you, sir, for your suggestions and feedback. Any other participants want to give their feedback?
Yeah, myself, Vijay Rajan. I would like to thank the
Namaste, sir.
Dean and management of GMRIT, management of Sairam Institute of Technology and other organizers for having given this opportunity to deliver a talk in this FDP. Once again, thank you all. Thank you so much.
Thank you. Don't think that this time only we called you. We may bother you in future for several. We have several FDPs in pipeline. Definitely, if you are interested, we'll take your services.
No, sir.
Vijay Rajan.
You can write my name. You don't need to ask me. Sir.
Because we had collaborations with other 5 prominent institutes also. This is the first one, and the remaining 5 also will in very soon we will like to conduct the workshops.
Yes, sir. You write my name and just to inform me, sir.
Okay. Good. Thank you.
Yes, sir. Yes, sir.
Thank you very much for your support, sir. Any other participant wants to talk? I think Vivek.
Yeah, Vivek. All. There are Adinarayana. Thank you, Vivek. Thank you.
Sir.
Thank you, sir. Thank you for organizing such a nice FDP.
Vivek is our alumni.
I'm so happy.
Sir, namaste, sir.
Namaste.
Thank you, sir.
Thank you, Adinarayana.
Sir, this is a wonderful chance and opportunity to once again greet and wish and salute all my wonderful faculty members and academia in GMRIT. And I first congratulate the Sairam Institute for being collaborated with the GMRIT because as I know, and as of many of us know, that GMRIT is one of the most prominent institutes in South India. So I really congratulate Sairam Institute for being collaborated with GMRIT and conducting such an thought-provoking and cutting-edge technologies in AI and machine learning. And I have a couple of technical points that I have jotted down during the sessions. I was very much impressed in explanations given in artificial intelligence, where the analogy between the transistors and ICs with respect to neurons and brain cells were analyzed by Krishna Kishore sir. I was very much fascinated to learn that. Thank you, sir. And also, I don't remember exactly the resource person's name, but one more resource person has given a wonderful clarity between machine learning and deep learning and artificial intelligence. So there is a clear classification between all those technologies. Of course, everybody use their names in hand, but there are particular differences between them. There are limitations between technology. Very much informative session and real-time image processing techniques and whatnot. There are many more things I have to discuss, but of course, many of us are waiting to leave. Want to take much time. Thank you for all the resource persons and the organizers that have done this program. Wishing everybody Ugadi and happy Ugadi and Shubhagrut New Year of Telugu New Year, I mean Indian New Year. And finally, Guru Brahma, Guru Vishnu, Guru Deva Maheshwaraha, Guru Sakshat Parabrahma, Tasmai Sri Gurave Namaha. Thank you, sir. Namaste.
Thank you. Thank you.
Thank you, Vivek. Thank you very much. Now I request Dr. V. Kannan sir to deliver vote of thanks.
Thank you, ma'am. Respected principals, Dr. CLV Prasad sir, Dr. K. Palanikumar sir, beloved director, Dr. Girish sir, chairman of Sri Sairam Institute of Technology, Sri Sai Prakash Liyamuthu sir, deans and HODs of GMR Institute of Technology and Sri Sairam Institute of Technology, faculties of GMR Institute of Technology and Sri Sairam Institute of Technology, participants from various institutes across the country and from Sultanate of Oman, and all others gathered here. A very good evening to all. It's my privilege to have been asked to propose a vote of thanks on this occasion. It is a great honor for me to thank our principals, Dr. CLV RSV Prasad sir, Dr. K. Palanikumar sir, and the director, Dr. Girish sir, and the chairman of Sri Sairam Institute of Technology, Sri Sai Prakash Liyamuthu sir, for providing the permission and all the needed facilities to conduct this online FDP on advanced signal processing communications using AI and ML techniques. I thank the deans and the HODs of both the colleges for supporting us in this FDP. I thank the guest of today's valedictory session, Dr. R. Vijayarajan, for his speech and spending time with us. Now, I would like to thank all the resource persons right from day 1 to day 5 who have delivered their informative lectures on the latest technology in time and helped us in conducting this FDP successfully. Now, I acknowledge my heartfelt thanks to all the members who worked tirelessly for the past few weeks with full dedication and sincerity to make this dream come true. Last but not least, I thank all the participants, those who have shown interest by attending this workshop, attending this FDP with patience in all the sessions and raised questions and make all the sessions interactive. Once again, thanks to all. Have a nice day and time. Thank you, one and all.
Thank you.
Thank you, sir.
Thank you, sir. Rajan sir, thank you.
Vijayarajan, thank you.
Yeah, thank you, sir. Thank you so
Thank
much,
you,
sir.
sir.
Happy to see you after a long time.
Kannan sir. Kannan sir.
Tell me, sir.
1 minute. Dr. G. Tamarai Selvi is there here. Just I would like to see if Madam is there.
Actually, sir, we have invited them, sir. I think they are not there. I asked them.
Okay,
I invited them.
Rajarajan sir, I think on that day I have seen him.
Yes, sir. Yes, sir. Both of them.
Sir is there now.
No, Rajarajan also not there. I think.
Okay. If they are there, just I would like to see.
Yes.
Right now. Okay, sir.
Yes, sir.
Right, Madam Jyoti, Madam, thank you.
Thank you, sir. Thank you very much. I would like to attend more FDPs from your college, sir.
We definitely will inform you, Madam. Madam, Durga Madam, make a note of it. Take the mail ID of Jyoti Madam,
Sure,
and
sir,
whatever workshops we are organizing FDPs, you inform her.
Yes, sir.
Definitely, sir.
Right.
Madam, we will inform you, madam, if any future workshops or FDPs are there.
Yeah, sir.
Thank you very much for showing your interest, ma'am.
Yeah.
Once again, I thank all the resource persons, participants, and management of all the colleges for helping us and supporting us for successful completion of this FDP. Thank you very much. Good evening.
Okay, ma'am. Thank you very much, ma'am. Thank you very much, ma'am, for your voice and Dr. Shivashankari ma'am's voice. Okay, as an anchor for all the 5 days. Okay, thank you very much, ma'am. Let me thank all the people once again. Thank you. Thank you, one and all, please.
Thank you.
Yes,
Sir, we can stop now, Kannan sir.
yes, sir. Yes, sir. You please stop, sir. Yes, sir. We can stop, sir. You please stop.